me, and you need to be writing down anything that needs to go down or get added to your paper, and any questions you have, then I'll take them, right? But I don't have time for kind of like side questions. I can take those later, okay? Just to make sure you have enough time to do what you need. So we're gonna read out parts of this together and then preview some of the directions. So I have some of these on the slides if someone want to make some notations in. Can someone, well actually a couple someones, we're gonna read the introduction. We're gonna do first paragraph to Raven, second to David, third to Sierra. Okay, go ahead.
Every cell is surrounded by selective permeable
Membrane.
which regulates the distance admitted to and out selectively
Permeable.
permeable membrane are membranes which allow some substances to cross much more easily than other substances.
Great, second person.
As you know, the process of diffusion move substances down the concentration
Gradient.
from regions of high concentration to regions of low concentration. Diffusion is an important process for moving molecules over short distances, such as the side of the cell.
Third person.
Each cell is surrounded by a selectively permeable membrane which regulates the diffusion of substances into and out of the cell.
Okay, so we're gonna stop there. What problems do you think a cell would have if it could not control what got into it or out of it? So take about 20 seconds and just jot down any thoughts you have. What would happen if the cell didn't have a selectively permeable membrane? If anything could get into or out of the cell? What could negative things might happen or positive things, I guess, if you think so? You can check with the person next to you if you need to, if you're a lot, okay? Share out one thought, because I have a couple people who are really struggling to think of something. Just one idea that you have. It doesn't have to be right necessarily, right? It's what you think. We'll say this one thing.
I said it could like lose too much water.
Could the cell lose too much water and shrink?
Yeah.
We were just talking about that. That could be a problem. So if you don't have one, you could jot that down. Jamia,
It wouldn't function correctly and it would die.
you think it might die if the cell membrane couldn't. Okay, that's a possibility. You could jot that down. You can keep going from there. You all have good ideas, but I want to keep moving, okay? We're going to go with the hypothesis. I'm going to read this out, and you're going to fill this in. So you need to make sure you filled this in for yourself before the lab. Today, you will investigate the movement of molecules across a synthetic. The word synthetic means fake. It's a fake membrane, okay? Selectively permeable membrane that you will use to model the membrane of a cell. Which of the following four molecules do you think would be able to cross the membrane? So you're going to work with four molecules, which you're pretty familiar with because we worked with them in Unit 1. Starch. Starch, remember, is a poly. Who can remind me what the prefix poly is telling us? Christy? Can't hear you, sweetie.
It means that one.
Mono means there's one.
No, it's two.
Is it two always? That's di. Anyone want to help us with poly? Poly? Who do I got? Alexis? Is it always 6? People are liking these specific numbers. Okay, Amika? More than one. So it could be 2, it could be 6, okay? But add for this, draw the line for yourself. If you forgot that, poly means many, more than one. It's gotta be more than one, okay? Saccharide stands for sugar, made up of many glucose molecules. So, who can tell me, is starch a large molecule or is it a small molecule? Based on just that description, is it a large or small molecule? Gabitha? It's large, do we agree? So if you need to, you can like note that this is a large molecule. I would maybe write it like next to starch to remind yourself. Unless you have a photographic thing. Perfect, I'm ready to digest it. Glucose. 6 carbon, 12 hydrogen, 6 oxygen. Who can recall, is glucose a monomer or a polymer? From unit 1, it was on the test. Is glucose a monomer or polymer? It's a simple sugar as a hint. It's a simple sugar. Anna?
It's not a monomer.
Uh-oh. Well, we all know the answer now. What is it? It's a monomer. Monomer, jot that down if you need to. It's a monomer. So it's a small piece, it's a building block. It makes up starch, right? Glucose is based by glucose, okay? We know iodine. Iodine is what we use in the lab when we tested for foods. You remember squirting the iodine out and it changed colors? We have it over on the side, okay? And it's I3, it's 3 iodine, that's all it is. And then, last but not least, we're all super familiar with water, okay? It's 2 hydrogens and an oxygen. What you're gonna fill in right now is, do you think, this is your guess, it's your hypothesis, but let's make it educated. Will this molecule cross the membrane? Will it be able to get through? And then tell me why you think that. What should I think about if I want to know which way, like whether the molecule can get through the membrane or not? What would I want to think about? Some of us might be really stuck right now if you're not super familiar with this. Alan? Size of what? Is it size of the molecule? Could that be a determining factor? So if my molecule is large, do we think it can get through the membrane?
No.
Maybe not, okay, and if it's small?
Yeah.
Okay, so write down your predictions. We'll move through yes or no, and why you think that. If you want to use size, that's great. If you have another idea, you can use that, as long as you have a reason. If you want to make it with your partner, that's fine, because like, we'll let it work together anyway. It's what we used to do our little test, to check if 3 iodine atoms bonded together. So iodine's 3 atoms bonded together. Would that be large or small, do you think? 3 atoms bonded together.
Medium.
I don't know, small, medium, we don't know.
Medium.
Medium, why do you think medium?
I said it's medium.
Why is medium? What does that mean?
Because
Yeah,
atoms
but-
are small, but 3 is bigger than 1.
Well, 3 is bigger than 1 atom,
So-
that's true.
Yeah.
Did you guys think water is big or small?
Small.
And water is 3 atoms, it's 2 hydrogens and an oxygen. So I don't know what
It's
you think
medium
about
too.
that. It's medium too, I guess. Okay, go ahead. Put down what you think. It's a prediction, it's okay if it's wrong. Nobody has a charge, a negative charge. Okay. I'm gonna freeze this because we're gonna move forward. Jot down what you have. Save your questions, okay? We're gonna move to the procedure, okay? All right, can I get 2 more readers who I have not gotten? So we're gonna get Christy and Asia to read the next 2 paragraphs. Christy, start us out.
Finish your predictions, use your 2 versus phase membrane solution.
Can you read real loud if you're all the way back there?
You would then place the tube in a beaker of iodine water and determine the charge of glucose diffusion having the tube for a iodine diffusion.
Okay, second person.
Water is the main component of both the solution inside the tube and the solution in the beaker outside the tube. The water can cross the selectively permeable membrane and diffuse both into and out of the tube. Which way would you expect more water to diffuse? Into the tube or out of the tube? What additional information will help you to make a more confident prediction?
Okay, so I'm gonna let you think on this, but there's a follow-up question or a follow-up statement that I'm gonna give you a way to do. Okay, so it says decide on a method to test whether more water has moved into the tube or out of the tube or there was no change. So you're making a tube. Okay? There's 2 ways we could do this, and I think one works better than the other. You can use a ruler and measure how much liquid is in your tube and see if it changes. Or you can use what I have out on the side, which I think has worked better in the past, a balance, and we're gonna measure the mass. So for where it says decide on a method, underneath that, you should write you're going to measure the mass of your tube before and after. Measure the mass of your tube before and after. So, if my tube weighs less at the end of the experiment, what's happened? Based on what they says about the movement of water. If my tube weighs less, it shrank, what happened to my, Al?
Means the water came out.
Means water left the membrane. What if my tube weighs more at the end of the experiment? So I put it on the scale, now it weighs more. What happened to the water? Did it leave the tube? Did it enter the tube? What happened? Justin? It entered the tube. So water, the math should tell us about how the water moved, okay? So flip this, and we're gonna make some last predictions. Okay, the tricky part here is you have to use your predictions, and they might be different than somebody else's prediction in order to do this. You're gonna use your predictions from the table on page 1 to predict the locations of each type of molecule at the end of the experiment. In the final state diagram below, write the letters that correspond to each type of molecule or ion in the places where they will be found after diffusion. So right now, all I want you to do is look at the initial state picture, the one on the left. So look at that. See what's inside the tube, what's outside of the tube. What molecules are going to be inside of the cell at the beginning of the lab? The tube represents my cell. What's inside of my cell? Ariel? Glucose and starch. Are we okay with that? Okay. What's outside of my tube at the beginning of the lab? Seal? Iodine. Okay. What you're going to do is fill in your final state based on what you thought. So how do you do that? Here's what I'm going to do. I'm going to go and I'm going to look at my predictions. So I'm going to flip back to this page. So flip back there and check it out for yourself. What did you think was going to happen? Flip back. My first molecule is starch. Raise your hand if you think starch is going to move through the membrane. You wrote, yes, it will cross the membrane. So no one said that? One person? No? You said that? Okay, so just Raven. Raven's the lone soldier there, okay? And Tabitha. Who thinks it's not going to move through the membrane? Who wrote no? So everyone else? Yeah? Brian? Okay. So if I was Tabitha or Raven, you said it could move through the membrane. So starch starts here. What would they write in the final state? Their prediction, not yours, right? What would they write? What are they going to draw? They think it can move through the membrane. Anika? She's going to write, they would write some S's on the outside. Would they all be on the outside? No. They would reach equilibrium, so some would be inside. So if I was Tabitha or Raven, you might want to do that. What about the rest of you who said it can't move? You said it can't get through, it's too big. What are you going to draw? What are you going to draw and where are you going to draw it? Sherry? Remains in the tube. So most of us are probably going to draw a picture like that, if that's what you predicted. So if you need to do it based on your predictions, go ahead now and do it.
Are we doing the rest of them?
Yeah, you can go ahead and do the rest of them if you're sure too. Same thing. Look at glucose. Did you say it would move? Draw appropriately if you did. Look at iodine. Did you say it would move? If so, you should have some inside and outside. If not, it's staying outside. Will they all move though? It is the membrane. This is the membrane. This is my cell, my membrane. Okay. Did you say starch would move?
Yeah.
So,
No, I
you
said
said no. So why did you draw it outside if it can't move through the membrane? Yeah, you should have like here, so it stays outside. This is the membrane. Guys, this is the membrane. I highlighted it in green. This is the cell. You're saying can it move out? If starch can't move out, you should draw them all inside. What about glucose? Can that move? Some people say yes, maybe, some say no, you should draw it then appropriately, inside or outside or both, depending on what you predict. Same thing for iodine. Okay, yes, Kate.
When you said move, you mean like based on where it was, will it switch places?
Yes, will not will switch places, will it diffuse, will it move from high to low concentration? Will it reach equilibrium? You're asking, will it reach equilibrium? Will it reach a balance across the membrane or no? Okay, yeah.
So, if, I said glucose.
Yep, so you drew 2 out and then maybe 2 in, because it would reach balance or equilibrium.
I was gonna
Yeah.
ask, do we move off?
Probably no, right? We're gonna reach equilibrium if they can move, okay? You'll find out. So why did you draw starch outside? If it's too many, you should draw. Okay, check yourself. I'm seeing a lot of this. Most of you, except 2 people, 90% of you said starch is too big. Is that correct? Yet I see people with starch written outside. If starch is too big, how does it get out the membrane? It can't. So fix your picture. If that's what you said. If that's what you said. If you didn't, like Tabitha and Raven, right? They might show some movement if they predicted different. That's fine. That was their prediction. Okay. Did you say glucose could move? You said no. Okay, so it's all inside. And then did you say iodine could move? Iodine. So why do you show all the iodine outside if you said it could move? Okay, let me re-clarify. I'm having the same questions. Freeze. Please be with me. Okay. This is what you are predicting. So I don't get the same questions 10 times, okay? You're looking at different molecules that are different sizes, right? Some are inside, some are outside. And you're trying to figure out, can they move across the membrane? If they can, they will, because they're at a high or a low concentration. So they're not at equilibrium in this first picture, are they? Are any of these molecules at equilibrium if this is inside and this is outside? No. None of them. So if they can move, they will. They'll move from high to low concentration, and they'll reach equilibrium again. So you're just predicting, based on what you said, can they move? If they can, they will. So we want to draw, what would they look like after they move? If I said none of them could move, I would just redraw the same picture. If I said some of them could move, I'm going to draw it with some of the molecules changing position based on whether they can move or not. So you predicted iodine could move. So would I draw all the iodine outside if I said it could move across the membrane? What am I going to draw? If you said iodine could move, some of you did, some of you didn't. David?
You have 3 inside, yeah.
Sure, about 3 inside, 3 outside, about equilibrium. If you said it could move. Is that okay? For some of us who are unclear still? Okay. Well, we will see. We may not have enough time to really fully do this today. Because quite honestly, this took much longer than I thought it would. So my bad. We'll see. Okay? We may have to set it up tomorrow. I'm going to see where we leave us. Okay? In fact, I think we're going to have to. There's no way we can get this done. Okay? Usually it's not this confusing, but it is today. Okay. Other questions about my prediction? Okay. Double check your prediction, make sure it's accurate, because I think what we're going to have to do is set it up tomorrow. Okay? So, let's make sure we're fully clear on what we're doing before we do that. Okay? Double check it. Yeah, Jessica. Why am I going to tell you that right now? I'll tell you. Don't worry. Please check your predictions. If I walked around that now, would they be accurate based on what you said? Yes. Yep. So, to help visualize, Jocelyn asked a good question. My tube is my cell. It's going to go in the beaker. It's like a little bag that you're going to put in a beaker of water. So it's a tube in a solution of water. Okay. I want to move to this bottom part. So now we're gonna go back and we're gonna move to the bottom part. So can someone read for us underneath my little diagram? You will test what we have. Khadija.
We will test for starch and iodine, we will move it using one color change. The solutions by themselves, iodine is red, starch is clear. When iodine and starch are in the same solution, the solution is blue. Using the predictions you made in the figure below, write the color of each liquid after diffusion and the final state.
Okay. So before we can do this, let's be real clear. So you will want to write this on the side as I'm writing this on the side. Some of us, I think, we can do better. Iodine by itself, what did she just read? What color is iodine by itself? Sherry? Brown. Starch by itself, it's over here actually. I made some, okay? What color is starch by itself, according to this and kind of based on this, Pierce? It's clear, so it's like kind of a whitish clear, but it's clear. It doesn't really have a color to it. Now, if I have iodine and starch touching each other, just like you did in that food lab about a month and a half ago, okay? What color is it going to turn? Here? Yeah, blue. I'd say kind of if you want to help yourself, like a blue-black, because it's a very dark color. It's almost like navy. So it's a very dark blue. Okay. So this depends completely on your picture, which is why I'm going to give you a minute to like look at it and I'll roam around and try to help you, because it depends on you and you might have predicted different than someone else. Let's say I predicted starch stays inside. Iodine moves. What do we think about glucose? Raise your hand if you think glucose is going to move through the membrane. It's small enough to move. So it's kind of like, it's not exactly half, but almost half and half. So I'm going to say glucose moves. Maybe it doesn't. Some of you said it didn't. If it didn't, all your G's would be inside. If it did, some inside, some outside. Okay. I need to predict my colors in the final state. When I start, iodine is outside. What color is iodine by itself? Brown. That's why it says brown in my chart. Liquid in the tube, let's look in the tube. I see glucose and starch. Starch by itself is clear, so they called it clear. Makes sense. I need to look at my picture here and decide now what happened. I look outside the beaker, in the liquid. I see G, glucose. I see I, iodine. Do I see starch? No. No. If I see iodine by itself without starch, what color is it? So for me, I would write brown. You need to see, if you said starch would move like Raven and Tabitha, you would write blue-black, right? Maybe, depending on what you predicted with iodine. I'm gonna look inside my tube. What do I see inside my tube? I see starch. I see iodine. Well, what's I plus S? Blue-black. So if this was my prediction, I would write blue-black. You need to look and decide, did you say iodine was going to move in? If you did, it's probably black, right? If you didn't, it might be clear though. So right now, make your prediction based on what we said. Check with your partner and see if they agree with you. Have them actually look at your picture. Do that now. I shouldn't see blanks. You need help. Okay. So you just need to get started? Okay. What do you guys have? Okay. This is your final one? Okay, so you say brown outside. The liquid in the tube is brown? Off of his. Okay. So you say the liquid in the tube is brown. I see I and S, so what color should the in the tube be? In the tube is in the tube. This is the tube. This is the tube. Okay. Okay, I will try to make it for you, but what do you guys have down for colors? Okay. Okay. Outside is brown, you said? Okay, so then you should have that down here. Okay, little clarifier. I know it's on 3 people's paper, so it must be a problem. You can label it. This is the tube. This is the tube. It is yourself. This is the beaker. Okay, so double check. Some of us were just a little confused about beaker versus tube. You're gonna have a cup. This is your beaker. gonna be wet, so prepare yourself. This is your tube you're gonna get. It's gonna go in the beaker. So here's your tube. Here's your cup or your beaker. Jocelyn doesn't like it, but okay, this is what you're gonna get. It's gonna be okay, I promise. It won't hurt you. It's just wet tube, okay? All right. Do we have colors predicted? Double check. Did you do in the tube or in the beaker correctly? Because I don't see anything on some people's papers. What's going on? Okay, so fill it in for yourself. All right. Okay. So let's review where we're at so far. How are we going to test for the movement of water? Look back at your procedure. How are we going to test for the movement of water? You have to flip to the front page. Don't pick your nails. Look for the answer. Daryl?
See how much it was absorbed inside the system, than originally was.
Yes. Okay then. I shouldn't. How are you going to test that though? You can't see it. With what? What are we going to do? Balance. Next. So check yourself. Water, we're going to use the balance. How are we going to test for starch? How will we know if starch moves? We just did this. How are we going to know if starch moves? Take a minute to talk to your partner because I'm going to pick on a random person and figure it out. There's no way we can start the lab today. You need to be able to figure it out. How are we going to test for starch? How will we know? How are we going to test for starch? Are you okay? You think so? Okay, what do you think? Okay. Let's go to victim 1, Anna. Okay, let's all look at Anna. Anna, how are we going to tell about starch here?
The color is gonna change.
The color is going to change. Very good. Why? What is it that will make the color change that when it touches starch?
I don't know, I just know when they touch, they become blue or black. I don't know.
What is they?
The two, iodine and
Iodine and starch. So what is it that touches the starch and changes color? What's the other term? Iodine. So how are we testing for starch is with iodine, and it will change color or no change. Okay, same. Okay. Do we know about glucose yet? No. So that's what we want to get to before we go. Okay. So you will use. You can look on here. We're at right under the chart. You will use a glucose test strip to determine whether glucose moves into the solution in the beaker or not. And you will use this method to determine whether water diffused in or out of the tube. We're using mass. Okay. So, for glucose, are we going to put something in there and then it's going to change color? Not necessarily that we know of, however, we actually are, but it's something you may not have used before. You're going to get one of these in this bag, or what we call glucose testers. And they actually sell them at the pharmacy for people sometimes who have diabetes, okay? You can take one and you dip it in the liquid and it will change colors. So instead of putting it, a liquid like iodine, into the beaker or the cup, we're gonna just dip it in and see, does it change color, does it not? And that will tell us if glucose is there. Is that okay for glucose? Okay, great. Here's your job. I'm gonna give you about 6 minutes till 10:35 to read the procedure. So the procedure is down below and it carries over onto the next page. I want you to read it. And then I want you to actually summarize for yourself, okay? What is the gist of what we are doing? If I was to ask you to explain it in a few sentences, what are you actually doing? Because if you go into this tomorrow not knowing what you're doing, you're gonna have a really hard time setting this up successfully and getting the results you want. So right now you should take until 10:35 to silently read the procedure, and on the side of it, write down in a few sentences, what are you doing in this lab? So right now I should see you reading and writing. Go ahead. By yourselves, yep. By yourselves, quits. Let's see if we can do it. If you're stuck on something, raise your hand and I'll come over if you're unclear about like a term or something you're not familiar with, okay?